there's a monolith there, a very unusual structure on this little potato-shaped object.
Approximately 54 years ago today, NASA landed its 2 scientists on the moon on July 20th, 1969, when Neil Armstrong, the first person to step on the moon, made his mark in history. But ever since he set foot on the moon, mysterious stories emerged, answers to which are still unknown to anyone today. In the desolate world of the moon, many such incidents occurred with them, which people still can't forget. After all, why couldn't NASA return to the moon again after 50 years? What exactly happened on the moon with the Apollo 11 mission? What was that unknown event, which Neil Armstrong captured in his room but never could bring the video before the world? Besides, why did NASA hide so many things about the moon? We'll tell you everything in detail in today's video. You are watching the Cosmic Discovery YouTube channel. Subscribe to this channel to watch videos related to space exploration. Number 1. This achievement was historic in every way imaginable. Monumental achievements pose a unique challenge because they set a high bar that's tough to surpass, especially when they leave an indelible mark on history. Consider the moon landing. How do you top that? The Apollo 11 mission represented the culmination of years of dedication and the shared aspirations of countless individuals. Neil Armstrong aptly hailed the Apollo 11 spacecraft as the most remarkable engineering feat of the 20th century. It was a bold endeavor undertaken by the finest minds in the USA, aiming to create a spacecraft capable of navigating through the Earth's atmosphere, landing on the moon, and safely bringing back its crew. Achieving this required meticulous planning and groundbreaking innovation every step of the way. The spacecraft not only had to ferry the crew, but also guarantee their safety throughout the demanding journey. The enormity of the task is underscored by the significant investment of time and resources poured into it. The United States couldn't afford to fall behind in the race to the moon. Too much was at stake, especially with the Soviet Union as a competitor. The country invested a staggering 8 years and $2.4 billion into the Apollo 11 mission. Adjusted for inflation, that's over $23 billion in today's money. This massive undertaking highlights the unwavering commitment and relentless dedication of the countless individuals who worked tirelessly to turn the seemingly impossible into reality. Number 2. A secret about the spacesuits. The story behind the spacesuits worn by the Apollo 11 crew is truly fascinating, filled with innovation and unexpected partnerships. While many view every aspect of the Apollo 11 mission as a marvel of engineering, it may surprise some to discover that the spacesuits were a unique case. They were indeed brilliantly designed, but didn't follow the typical engineering path. Instead, it was a lingerie company that played a crucial role in their creation. Armstrong's custom-made spacesuit, known as Model A7L with serial number 056, came with a hefty price tag of around $100,000 at the time, equivalent to roughly $670,000 in today's currency. No expense was spared in ensuring these suits could withstand the extreme conditions of the lunar surface, from scorching temperatures of 240 degrees Fahrenheit in sunlight to bone-chilling minus 280 degrees Fahrenheit in the shadows, all while protecting the astronauts from deadly solar ultraviolet radiation. Even the slightest stitching mistake could make the suit unfit for use. While crafting a suit capable of enduring such extreme conditions presented its challenges, the real accomplishment lay in ensuring flexibility without sacrificing durability. The International Latex Corporation in Dover, Delaware, was entrusted with the task of crafting the spacesuit, yet it was Playtex, a company primarily known for its work with bras and girdles, that unlocked the secret to flexibility. This unexpected partnership between a lingerie company and NASA's spacesuit engineers resulted in a suit that enabled the astronauts to move comfortably while remaining fully protected. As a BRA manufacturer, Playtex played a significant role in the success of the Apollo 11 mission. Number 3. The mission faced a close call. Discussing remarkable achievements, the Apollo 11 mission, undoubtedly monumental, encountered its fair share of obstacles and dangers. Neil Armstrong and Buzz Aldrin, navigating the lander during the mission, narrowly escaped a potential catastrophe. Following their iconic moonwalk, as the pair prepared to rendezvous with the command module, they encountered a critical problem. The circuit breaker for the engine arm ascent malfunctioned. This switch was responsible for arming the engine that would elevate the lunar module back into orbit. Accidentally, the switch was broken off, leaving the engine arm ascent circuit breaker in the open position. Consequently, the engine failed to ignite when the module needed to return to the orbiting command module around the moon. Aldrin ingeniously inserted a felt-tip pen into the opening where the circuit breaker switch was meant to be and pushed it to close the circuit. This impromptu solution ensured that the engine arm ascent circuit breaker was activated and ready for use when necessary. With the issue addressed, the ascent engine fired successfully, propelling them off the lunar surface. However, their trials were far from finished. Following a lengthy journey lasting 195 hours, 18 minutes and 35 seconds, Apollo 11 descended into the Pacific Ocean for recovery. However, once again, things did not proceed as anticipated. Unfavorable weather conditions caused the spacecraft to land 13 miles farther from the recovery ship USS Hornet than planned. This situation nearly led to a disaster, but thankfully the crew emerged unharmed. The resourcefulness and calmness exhibited by the Apollo 11 astronauts in the face of adversity underscore their extraordinary bravery and creativity. Despite the perilous situations they encountered, these individuals successfully guided the mission to its triumphant conclusion. Number 4. The Soviets wanted to beat the USA to the moon. In the 1960s, there was an intense competition between the Soviet Union and the United States to reach the moon. While President Kennedy's iconic speech in 1961 openly declared America's goal to land on the moon, the Soviets kept their lunar ambitions secret until much later. It wasn't until 1989 that the Soviet Union finally acknowledged their lunar aspirations. Despite their initial denial, the Soviets were actively involved in their lunar program, which persisted even after the historic Apollo 11 mission successfully touched down on the moon in 1969. The Soviets opted to conceal their objectives to avoid admitting defeat in the moon race and maintain their public image. Instead of direct lunar landings, the USSR focused on robotic missions and unmanned spacecraft, such as the Lunar program. The Luna missions aimed to achieve various goals, including lunar orbiting, soft landings, and sample returns. However, the Soviet lunar program encountered numerous challenges and setbacks, including technical issues, problems with launch vehicles, and financial constraints. One significant setback was the crash landing of the Luna 15 spacecraft, which occurred just days before the successful Apollo 11 mission. In summary, the USA emerged victorious in the space race by reaching the moon before the Soviets, marking a historic milestone in space exploration. Number 5. The Saturn V Rockets. Almost blew up, the Saturn V rocket stands as a remarkable achievement in American aerospace engineering, playing a crucial role in the triumph of the Apollo 11 mission. However, its astounding power also brought with it considerable risks, as demonstrated by a nearly catastrophic incident in 1968. Developed by NASA to serve as a super heavy lift launch vehicle, the Saturn V was entrusted with the task of launching the Apollo spacecraft into Earth's orbit and beyond, towards the moon. However, doubts regarding its safety persisted following a harrowing event during the Apollo 6 test flight in 1968. During this test flight, the Saturn V rocket encountered multiple malfunctions. Among the most notable issues was the failure of the second stage's engines to restart for the second burn. This led to a lower than planned orbit and had repercussions on the mission's overall success. The immense rocket hovered perilously close to disaster as engineers dreaded the possibility of a catastrophic explosion. Such an event would have unleashed a colossal fireball stretching 1,400 feet wide and reaching searing temperatures of up to 2,500 degrees Fahrenheit. Despite grappling with multiple malfunctions, the ground crew sprang into action to mitigate the looming risks. Fortunately, the Saturn V defied the odds stacked against it. Although the mission fell short of achieving all its objectives, the crew and ground personnel toiled tirelessly to safeguard its success. They managed to glean invaluable data and insights, instrumental in refining subsequent Apollo missions, notably culminating in the triumphant lunar landing of Apollo 11 in 1969. Even today, the Saturn V stands as a testament to human resourcefulness and resilience, realizing its monumental goals without any loss of life or significant mishaps. Number 06. Why did NASA never return to the Moon? The Apollo program represents an extraordinary milestone in human history. However, despite its monumental success, NASA never revisited the Moon following the conclusion of the Apollo missions in 1972. But why? Well, to begin with, the Apollo program came with an exorbitant price tag. With the US government already grappling with financial constraints, maintaining the necessary funding for further lunar expeditions proved challenging. The development of new spacecraft and technology required for moon missions would have incurred astronomical costs. Additionally, after the initial euphoria surrounding the Apollo 11 mission subsided, public interest in lunar exploration dwindled. Many came to view the moon landing more as a symbolic triumph than a scientific endeavor, thereby alleviating the pressure on NASA to pursue additional lunar missions. Consequently, NASA redirected its focus toward other initiatives, such as the development of the Space Shuttle program and exploration endeavors in low Earth orbit. Given the cost-effectiveness of reusable spacecraft compared to lunar missions, NASA altered its priorities. Furthermore, investments in projects such as the Hubble Space Telescope and the International Space Station were given precedence. Moreover, the Apollo program was predominantly motivated by political factors, particularly the Cold War rivalry between the US and the Soviet Union. Once the goal of landing humans on the moon and showcasing technological superiority was achieved, the political impetus for further lunar exploration dwindled. While the Apollo missions yielded valuable scientific insights, doubts emerged regarding the ongoing scientific relevance of continued lunar exploration. NASA had already gathered samples and data from the moon, leading some scientists to question the necessity of additional missions. The Apollo missions were also fraught with dangers, exemplified by the perilous incident aboard Apollo 13. Despite technological advancements that could enhance safety, the inherent risks of human spaceflight persisted. Heightened public apprehensions regarding the safety of space travel and the potential political ramifications of accidents were significant considerations. Even today, challenges such as exorbitant costs, safety apprehensions, and scientific significance remain pertinent. Nonetheless, there are renewed efforts underway to return humans to the moon, indicating the potential commencement of a new era of lunar exploration, albeit with multifaceted challenges to be addressed. Number 7. Neil Armstrong was misquoted. Neil Armstrong's iconic declaration upon stepping onto the lunar surface has resonated throughout history, yet it may have been inaccurately reported. The renowned phrase, "That's one small step for man, one giant leap for mankind," is ingrained in our collective consciousness. However, Armstrong later contended that he actually said, "That's one small step for a man." Why the discrepancy? A glitch in the audio transmission rendered the AA in "for a man" inaudible, resulting in the misquotation. This minor grammatical nuance prompted discussions and scrutiny, with Armstrong himself acknowledging the inconsistency. In 2006, computer programmer Peter Shanford scrutinized the recording and identified a brief, indecipherable sound between the words "for" and "man," implying that Armstrong did indeed include the pivotal A in his statement. Ultimately, whether Armstrong uttered "a man" may appear inconsequential, but the words were spoken at a pivotal moment in world history, adding significance to the debate. After all these years, The revelation that the line might have been accurately delivered brings resolution to this linguistic contention. Number 8. The lunar dust problem. If the goal is to revisit the moon and conduct longer surface explorations for extended research purposes, there's a challenge to overcome. The lunar surface is not as hospitable as it appears. Recognizing this obstacle, NASA embarked on an ambitious mission in 2015 to enhance the durability of spacesuits. The aim is to extend their lifespan to withstand 100 extravehicular activities, EVAs, totaling around 800 hours on the moon's surface. Achieving this goal would significantly surpass the duration of the Apollo missions and is essential for establishing a sustainable base on the moon. However, what impedes progress toward this objective? The answer lies in lunar dust. Unlike the dust found on Earth, lunar dust consists of fine particles and sharp glass shards. It poses substantial risks to spacesuits and equipment. Lunar dust is formed by micrometeorite impacts, which cause it to adhere to surfaces due to its dry composition and the absence of natural erosion mechanisms. Additionally, when lunar dust is exposed to solar radiation, it becomes electrostatically charged, leading to the accumulation of positive and negative charges on dust particles. This poses challenging conditions for astronauts as the charged dust adheres to spacesuits and equipment. In response to this challenge, NASA launched the Breakthrough, Innovative and Game-Changing Idea Challenge in 2021. Winning solutions introduced innovative approaches, including conductive fibers, electrically charged brushes powered by UV radiation, and biomimetic fabrics inspired by insect structures to mitigate the impact of lunar dust on spacesuits. NASA aims to incorporate an electrodynamic dust shield system into the layers of existing spacesuits. Carbon nanotubes emerged as a suitable material for flexible electrodes due to their superior electrical conductivity and strength, outperforming traditional materials such as silver and copper. This innovation will enable spacesuits to generate electrical currents to actively repel dust. Although this initiative is ongoing, NASA's efforts underscore the agency's dedication to surmounting obstacles and pushing forward lunar exploration. By tackling the lunar dust challenge, NASA seeks to establish the groundwork for long-term human habitation on the moon. Number 9. Carbon nanotubes. When it comes to extending the duration of lunar missions, NASA is turning to carbon nanotubes, CNTs. These nanotubes offer a lightweight solution to enhance the durability of spacesuits. Unlike traditional conductors like copper, CNTs require significantly less mass to create an electrodynamic dust shield. This characteristic makes CNTs an excellent choice for reducing weight while maintaining high conductivity. NASA's approach involves integrating CNTs into the outer layer of the spacesuit by weaving them into the orthofabric layer, which consists of materials like Gore-Tex and Kevlar. To address concerns about the potential breakdown of the orthofabric due to high voltages, the dust removal system was limited to a safe voltage level for the insulating material. By generating electrical fields, the electrodes repel charged dust particles, effectively removing them from the surface of the spacesuit. A knee-joint prototype featuring carbon nanotube electrodes showcased remarkable efficiency in removing dust, with up to 96% of simulated lunar dust effectively eliminated. This groundbreaking technology offers hope for upcoming lunar missions, where the dust removal system can remain active throughout extravehicular activities or be activated manually as required. Such dust prevention technology has the potential to counteract the threat posed by abrasive lunar dust to future lunar colonies, presenting a straightforward yet impactful solution with far-reaching implications for space exploration. Mastering this technology could pave the way for lunar surface colonization and even expedite the mining of valuable minerals and metals within a few decades. Number 10. First religious ritual conducted on another celestial body. Before the mission, Buzz Aldrin wasn't widely recognized for his religious beliefs, but privately, he had made arrangements for a significant event upon landing. Being a Christian, He viewed the lunar landing as a chance for a profoundly personal expression of faith. Aldrin had coordinated with his minister to partake in communion on the lunar surface, seeing it as a symbolic act of worship in the expansive realm of space. This private ceremony, carried out shortly after the iconic moonwalk, stands as a lesser-known and frequently disregarded episode in the annals of space exploration. He aimed to keep this solemn ritual confidential due to NASA's apprehension about potential public scrutiny and controversy. While he wasn't the first individual to engage in prayer in space, he did become the pioneer in partaking in a Christian sacrament on the lunar surface. Amidst the vastness of space, Aldrin brought forth sacred bread and wine, blessed on Earth, and conducted the Holy Communion. This occurred as he prepared to step out of the spacecraft and become the second person to set foot on the moon. He respectfully asked for a moment of silence, extending the invitation to his fellow astronaut as well. Armstrong, in a gesture of respect, chose not to partake and quietly observed the proceedings. NASA chose to keep Aldrin's communion ceremony confidential, apprehensive of a recurrence of the controversy that arose during the Apollo 8 mission when astronauts recited a passage from the Book of Genesis, leading to a lawsuit against the agency. Nevertheless, with the passage of time, Aldrin's actions have earned admiration and respect. Despite our diverse beliefs and backgrounds, we all share the same Earth, gaze upon the same moon, and feel the warmth of the same sun. In the vast expanse of space, such moments serve as poignant reminders of the shared bonds that unite us as fellow human beings. Number 11. Traces left behind on the moon. The evidence of human presence on the moon is apparent in the remnants left behind by the Apollo 11 mission. While many may recall the iconic American flag planted on the lunar surface, there are countless other human marks scattered across the moon. Among these, the footprints left by Neil Armstrong and Buzz Aldrin are perhaps the most enduring and symbolic. With no atmospheric erosion to wear them away, these footprints could persist for centuries, serving as tangible reminders of humanity's initial steps on another celestial body. Additionally, a portion of the landing module stage was intentionally left behind, carrying a plaque bearing a historic inscription. Here, men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind. This gesture, coupled with the placement of tools and equipment, aimed to commemorate the monumental achievement and convey a message of peaceful exploration to all. However, not all traces left on the moon carry such noble significance. Due to limitations in weight, the astronauts were compelled to discard various items, including hammers, scoops, and even human waste. Yes, you heard that correctly. In total, 96 bags of human excrement were left behind. These practical challenges and sacrifices underscore the realities of space exploration. Number 12. The SLS system. The Space Launch System, or SLS, embodies NASA's ongoing commitment to undertake ambitious space exploration missions using robust rockets. Taking cues from the legendary Saturn V, the SLS aims to transport substantial payloads beyond Earth's gravitational pull. It integrates key elements inspired by NASA's past achievements, including the utilization of main engines inherited from the Space Shuttle program, which served faithfully for 3 decades until 2011. These engines boast a stellar performance history, having executed numerous missions with commendable reliability, thereby offering a cost-efficient alternative to developing new propulsion systems. Moreover, the involvement of many contractors who contributed to the Saturn V era, with Boeing serving as the primary contractor for the SLS, ensures a seamless continuity of expertise. This long-standing partnership not only facilitates the exchange of knowledge, but also sustains employment opportunities across Florida, Louisiana, and Texas, benefiting local economies. The development of the SLS is deeply rooted in America's industrial history, with facilities like McCoud, originally established during World War II, evolving to support NASA's missions since the Saturn program in the 1960s. Today, the SLS project encompasses contributions from various states, showcasing a nationwide endeavor to advance space exploration capabilities. Designed to be the most powerful rocket ever constructed, the SLS aims to facilitate deep space exploration, including crewed missions to the Moon, Mars, and beyond. Expected to be a cornerstone in future Moon colonization and mining ventures, the SLS boasts heavy lift capacity, enabling the transportation of larger payloads essential for sustained lunar missions, such as habitats, equipment, and supplies. Moreover, its capability to carry specialized payloads tailored for mining operations is noteworthy. Additionally, the SLS holds promise in establishing lunar infrastructure, including spaceports or refueling stations, which could further bolster exploration and mining endeavors. Overall, the SLS signifies a significant leap forward in space exploration capabilities, offering immense potential to pave the way for future lunar colonization and the utilization of resources beyond Earth. Number 13. Private space exploration efforts. The rise of a robust private space industry represents a notable transformation in the realm of space exploration in recent decades. Companies such as SpaceX, Blue Origin, and United Launch Alliance have engineered potent rockets capable of propelling payloads into deep space, disrupting NASA's conventional role as the principal provider of space transportation services. SpaceX's Falcon Heavy, for instance, made its debut in 2018, establishing itself as the most powerful operational rocket globally. Similarly, United Launch Alliance and Blue Origin are actively developing heavy-lift rockets that rival the capabilities of NASA's Space Launch System. While these private rockets may not match the sheer power of the SLS, they pose significant competition. Some proponents even argue that the burgeoning private industry could potentially eclipse NASA in rocket development. Nonetheless, NASA underscores the importance of collaboration between public and private entities in propelling space exploration forward. Instead of regarding private companies as adversaries, NASA perceives them as collaborators in a shared mission. The agency envisions a future where both sectors synergize, leveraging their respective strengths to accomplish mutual objectives. NASA plans to engage commercial companies in the construction and operation of lunar vehicles, emphasizing the significance of public-private partnerships in advancing space exploration initiatives. This shift will not only foster innovation, but also empower private companies to take ownership of their designs and technologies. However, public perception of space exploration has evolved since the Cold War era. While NASA remains committed to its vision for space exploration, there is a growing skepticism among Americans regarding the value and urgency of returning to the Moon. Some argue that NASA should redirect its efforts towards tackling pressing global challenges like climate change, leveraging its expertise in satellite technology and scientific research. Nevertheless, space exploration holds promise in addressing urgent global challenges, such as climate change through its proficiency in satellite technology and scientific research. Satellites equipped with advanced sensors yield comprehensive data on Earth's climate system, enabling the monitoring of crucial environmental indicators like temperature, precipitation, and carbon dioxide levels. Space missions provide unique vantage points for studying Earth's climate from a global perspective, fostering the development of precise models and insights into climate change dynamics. Moreover, technological advancements propelled by space exploration, alongside international collaboration, can pave the way for innovative solutions to mitigate the impacts of climate change, underscoring the pivotal role of space exploration in tackling pressing global issues. Therefore, a collaboration between the public and private sectors in space exploration, particularly in future lunar missions, can offer numerous applications for addressing challenges on our planet. Thanks for watching. If you enjoyed this video and want to see more fascinating content about space exploration and science, don't forget to subscribe to our channel and hit the notification bell so you never miss an update. And be sure to check out our other videos for more captivating insights into the wonders of the universe. Until next time, keep exploring, keep learning, and keep reaching for the stars. See you in the next video.